Hello everyone, myself Dr. Khan, Associate Professor of Mathematics, Jagannath International Management School, Poisson. I welcome you all in this video. In this video, we will discuss questions on Poisson distribution. As you are aware, in our previous video, we discussed the Poisson distribution, its basic concepts, and proofs regarding to the formula of Poisson distribution and mean and standard deviation of the Poisson distribution. In this video, we will discuss questions or practical approach, how we apply practically the Poisson distribution to solve the questions. So here we have a question. Example 1. Assume that the probability of an individual coal miner being killed in a mine accident during a year is 1/2400. Use appropriate statistical distribution to calculate the probability that in a mine employing 200 miners, there will be at least one fatal accident in a year. So now we will solve this question. Here, so we have the solution. Okay, so here given probability P is equal to 1/2400 and n is equal to 200. Right? We know that the mean m is equal to np, that is 200 divided by 2400, that is 1/12. It is being asked at least one fatal accident, right? So P at least one. P at least 1 is equal to P 1 or 2 or 3 or 200. Okay, so we can write P1 plus P2 plus P3 plus so on up to P200. P200 equal to, we can write 1 minus P naught. 1 minus P naught and 1 minus, write down P naught here, e to the power minus m, m to the power 0, e to the power minus m, m to the power 0 divided by factorial 0. So 1 minus e to the power minus 1/12, 1 minus e to the power minus 1/12 factorial 0 1 equal to 1 minus 0.92 equal to, we can say that 1 minus 0.92 is equal to 0.08. 0.08 is the answer. So this is the way to solve questions related to the Poisson distribution. Right? We have another example using Poisson distribution. Example 2. Using Poisson distribution, find the probability that the ace of spades, that the ace of spades. Ace of spades will be drawn from from a pack of well shuffled cards, at least one well shuffled cards, at least once in 104 consecutive trials, at least once in 104 consecutive trials. So we have the given question: using Poisson distribution, find the probability that the ace of spades will be drawn from a pack of well shuffled cards at least once in 104 consecutive trials. Now we will solve this. Probability of the ace. So solution we have probability of the ace, probability of the ace of spades is equal to P is equal to 1 by 52, because 52 are the total number of cards, and out of 52 total number of cards we have one ace of spades, and n is equal to 104. Number of trials how much? 104. N is equal to 104. So m is equal to what we have? M is equal to NP, implies m is equal to 104 by 52, right? That is 2. So mean is equal to 2. M is equal to 2 we have. Okay. Now PR by Poisson distribution, PR is equal to e to the power minus m to the power r divided by factorial r, equal to e to the power minus 2 to the power r divided by factorial r. So 1 upon e square 2 to the power r, we can write 1 upon e square 2 to the power r by factorial r. Okay. So P at least once, P at least once is equal to P1 plus P2 plus P3 plus so on plus up to P104, equal to, we can write 1 minus P naught. 1 minus P naught is equal to 1 minus 1 upon e square into 2 to the power 0 divided by factorial 0, or we can write 1 minus 1 upon e square into 1 and 1 minus 0.135, that is 0.865. These values are given in your question paper also, or in questions. Okay, so here you can solve questions like that, like this. Okay, we have another example to solve. Example 3. Okay, so in a certain factory producing cycle tires, there is a small chance of in a certain factory, in a certain factory producing cycle tire, there is a small chance of chance of 1 in 500 tires, 1 in 500 tires to be defective, The tires are supplied in lots. The tires are supplied in lots of 10 using Poisson distribution, calculate the approximate number, calculate the approximate number of lots containing no defective, containing no defective, right? So we have solution. We are given P is equal to 1 by 500, N is equal to 10 here, so M is equal to NP. So 10 into 1 by 500, that is 1 by 50. So M is equal to 0.02. PR is equal to e to the power minus m to the power r divided by factorial r, right? For no defective, probability of no defective, probability of no defective, that is P at 0 is equal to e to the power minus 0.02 into 0.02 to the power 0 divided by factorial 0 equal to minus e to the power 0.02, right? So we have the final value 0.9802. This is the final value for that. Okay, so this is the method, these are the techniques, these are the method to solve the questions related to the Poisson distribution, right? So I hope you understood the concept, the methods related to the Poisson distribution. Okay, so try to do a lot of practice to understand the concept, because a practice makes man perfect. So please try to solve a number of questions, lot of questions on the topic, so that you get familiar with the tips and solutions. So I hope you understood. So thank you all, thank you very much.